So we've already seen the video of the robot working. So here are some highlights of the code. So the beginning of the code is always your global variables. Right now, I have all the global variables at the beginning of this code. One thing that I could do to clean the code up is I could actually move all of these global variables over into a helper file. So you can make a robot motions.ino file and put all of your functions and your constants in here. So if you notice here, right now I have all the robot motion functions in here. So I have stop, forward, backward, spin, etc. So what I could do to clean this up even more so that it's only the stuff I absolutely need, I can copy all of this. All right, just to keep from, I think you do have to make the include.h for these. Let me try to do that. I'm going to make another tab. And I'm going to call this tab constants.h. Yeah, I didn't like that. So let's try this here. So it's looking for either quotes or brackets. So it actually told me that. So I'm going to try brackets first. And now, see how it does now. If it doesn't work, I can try quotes. The main thing I want to make sure is can it still see global variables, any global functions, etc. Even though my code is now, the main code is now down to just having the setup and the loop function. And the good news is, yes, it now works. So I just had to get the syntax correct. Okay, so now we're going to move on. And now in our setup function. So main things we have here is we have our extender board set up. We have our enable pins for our motors. We have our right and left motors set as outputs. Then we have the PWM pins declared for our left and right motors. Then we enable the left and right motor. And then we set our RC type. This is all for the sensor array, where we're going to read our sensor pins for the line follower. Then we set the speed for our motors. We turn on the I2C so that I can use my LEDs for my state indicators. Then I just turn all the LEDs on, indicate that the robot is starting, the robot's speed, and then I turn it off. Now in our loop function, for now, I'm not going to make a separate function. This is where I'm going to put the line follower. So what you're going to see in this loop function, the first thing I'm going to do, thinking about sense, plan, and act, which is what we do for robot behaviors, is I am going to set a max line value of 0, and I'm going to read the sensor values. Remember, I decided not to use the calibrated data. Now I'm going to go through the sensor values and determine what the maximum number is, knowing that the maximum number is going to represent where the robot sees black. If you're doing a white line, you would be looking for the minimum number. So then it's going to loop through, find that maximum value, and then it's going to loop through again, and any reading that is greater than or equal to that maximum value, I'm going to set it to 1. Otherwise, I'll set it to a 0. The benefit of doing this is I don't have to write code using 1000s, 2000s, 1500, etc., which is the raw data. I now can use zeros and ones. And the reason you want to do this is because now I can just use Boolean algebra, ands and ors with ones and zeros in order to make all the decisions about how the robot has to move. So for example, the code I just ran where I talked about I only wanted the center readings to make the robot move forward. I'm going to try to make this smaller so you can see what I did here. Is I said as long as any combination of those 4 center sensors is a 1, then the robot should move forward, okay? So I'm not making the robot oscillate yet because I'm happy enough with those small values. So if any of 2, 3, 4, 5 gives me a combination of 1, 1 or 1 or 1 or 1, and because I need to make sure I keep this straight for when I pass over the markers, 0, 1, 6, and 7 are not reading a 1, then the robot should just simply drive forward, and I turn on 3 LEDs to indicate that the robot is in the forward state. Then if I determine that none of those are giving me a 1, so that means not a 1 on 0, 1, 2, 3, 4, or 5, which means no line, the robot should stop. So this is what you've seen in the video so far. Now we're ready to turn on some proportional control to see how to adjust for when the robot starts to drift off the line.